All right, so in 1959, a Dutch mathematician named, what was his first name? Edgar Dijkstra came up with this more efficient algorithm to find the shortest path. And so these steps will kind of be run through, but the idea would be is that initially you start off and say, okay, this is where I want to start. So I call this, the beginning location. We circle it, and then we go through and put a 0 on that one. And then what we do is we look at all the adjacent vertices and go ahead and put their links to that vertice, and then kind of continue this process. And so here it is broken down with symbolism. So here we go. Let's take a look at it. So the first thing we're going to do is, because we know we want to start at K and go to S. So we're going to start off, and we can see on here we've got the 0 circle. I'm sorry, K is circled. All right, and we labeled it with a 0. All right, then we're going to label the vertices adjacent to K. And so we went out here to A, and we put 400 on A. So let's put a 400 right there. And we went out to C, and we put a 1,000 on there. Looking at this, we can clearly see that A is going to be the closest. So step 2 would be is that we would go ahead, and so now I'm right here. I'll go ahead and circle this so I know this part in B. And so here I am. I circled A. But now I need to relabel B and D, because now our current path is going to be from K to A, and now we got to look forward to the adjacent path. So we're going to get rid of the infinity symbols, and we're going to identify KAD as 1,500, and we're going to identify KAB as 800. So to start the next step, we'll change colors again. So in this next step, we can see that vertex B has the smallest label, so we'll circle vertex B. And then we'll take a look and say, okay, so we want to go from B and move forward, then we could either go to C, but the thing is C already has a shorter path. So if we went from K to A to B to C, we would be at 1,600. But instead, we could just look at it as 1,000, because that would get us to the same spot. So we just default to the shortest. But if we go from K to A to B to D, then that's just going to be a total of 1,500. And so I'm sorry, I just did that wrong. It would be K to A, that's 4. A to B, that's 4, and 3 more would be 1,100. So now this number is going to be 1,100. And so we know that we have 1,100 or 1,000. And I guess the problem is I kind of got ahead of myself a little bit there with that. So making sure that each time we're kind of going back through and circle and then relabeling those adjacent vertices, which is what I didn't do, and that messed me up. And so now I have my path at this point is I can either go from I'm only looking at adjacent vertices now. So now I'm sitting here at D, and I'm like, okay, well, how can I get to S? Well, there's only one way to get to S. And so by adding that 700 onto the 1,100, we come out with a total distance of 1,800. So the difference really between the two is that in geometric, you're kind of like writing down and kind of like adding up as you go. And each time you're kind of reevaluating. This time you're kind of taking a little bit further step forward. And so for assessment for this section, that's really all we're doing is just practicing finding the shortest path. And obviously the directions do say to use one method or the other, but as long as you're finding the shortest path, that's the key thing that I'm looking for. All right. Thanks so much.